Okay, let's talk a little bit about titration curves. We'll start by talking about strong acid, strong base titration curves. And they all work without any equilibrium taking place. The equivalence point will be 7 because the solution will just be neutral water with a salt dissolved that's neither acidic nor alkaline. In our case, we're going to titrate 100 milliliters of 0.1 molar perchloric acid with potassium hydroxide to produce water and potassium perchlorate. So there's 0.1 molar perchloric acid, and we got 100 milliliters of it. We know the concentration of the potassium hydroxide is 0.1 molar. We don't know how much we need to get to an equivalence point, but since the concentration is the same, the mole to mole ratio is the same, we'd assume 100 milliliters without doing the calculation. So what we're going to do is we're going to look at the pH before any base is added, and then we're going to look at about 20, which will be somewhere where I've started neutralizing the acid but not completely. And then we should look at it after 100 because that's when we think it should be completely neutralized. So let's look at that on paper. So what's our pH before any is added? We're talking about the 0.1 molar. So for that first part, the pH is going to be equal to negative the log of the hydrogen ion concentration. And since this is a monoprotic strong acid, the acid concentration is the same. So log of 0.100. So our pH is 1.00. So that's pretty straightforward. Now, so that was our initial. So what happens after 20 milliliters or 0.0200 liters of 0.1 molar? So now what I've got to do is figure out my amount that's being neutralized. So I'm going to have 0.100 moles per liter. And I've got 100 milliliters of that, so 0.100 liters. That's going to cancel, and that's for my nitric acid minus 0.100 moles per liter times 0.02 liters, and find out how many are left. So if we run that through our calculator, we're going to say we've got 0.00800 moles of perchloric acid in excess because I haven't added enough base to neutralize the acid. So then our pH is going to be equal to log of 0.00800. And that'll be 2.096. So we're going to round that up and we're going to call that 2.10. So pH did go up some. But notice I haven't done any equilibrium calculations because there's no equilibrium present. It's just a straight neutralization. We're not worried about the water. And the salt is neutral, so we're just talking straight neutralization, how much acid is in excess. Now if I add 100 milliliters I'm going to completely neutralize that. So how much do I have in excess? Without even really doing the calculation, I've got no excess. And I just have an aqueous solution of KClO4. The water's not going to affect the pH. And so essentially I've got a neutral solution of water with potassium perchlorate. Perchlorate comes from perchloric acid, which is a strong acid. The potassium comes from potassium hydroxide, a strong base. So that salt is neutral. Without really doing any calculations, the pH at the equivalence point should be 7.00. And that's a strong acid, strong base. If I kept going, the pH would be determined by the amount of base that you've added in excess. So if we come back and we look at the curve that you generate a S-shaped curve like this, where the equivalence point is represented by the red line. The equivalence point would be what? It would be 7, pH of 7, and based on the base added. This one's a pH of 0.05 liters of 0.1 molar HCl titrated with 0.1 molar sodium hydroxide. But regardless, the strong base curve looks like a little S shape like that with an equivalence point at 7. And the equivalence volume you'd read off of the x-axis.